Alright, so this chapter is on sets and maps, but that's the title, but actually more if it's a chapter on hash tables. Sets and maps are two data structures we're going to learn how to use. They're kind of the last two before we get into graphs, which is not something we'll code up, and not something that Java has natively provides. So in sets and maps, they're very interesting because you can use a tree to build them. You can create a tree set and a tree map, and those will do all the operations we talk about in log n time. But we use maps and sets to talk about hash tables. We use them as an excuse to finally build a hash table and reveal a hash table, and then we're going to be able to use maps and sets to do all sorts of constant time operations like adding something to a set, checking if something is in a set, removing something from a set. Those will all be done in constant time with a nice giant asterisk on that. So we're going to use these map and set objects. We're going to learn what we can use them for. Sets are kind of going to, and I'll just summarize here, sets are kind of the ultimate checkbox class, right? You can see whether you've seen something before by throwing it into a set. Maps, on the other hand, are used for two giant purposes, which are categorizing things and counting things, which are amazingly, which have amazingly broad applications. So once we learn about the map, so we'll review the map and set first. Then we're going to learn about hash coding, and we're going to show how we use that to build hash tables. Now the interesting thing is, so the way I'll present it is I'll present us with the three challenges that occur when trying to build this constant time operation, a backbone for the maps and sets called a hash table. So this constant time data structure will have three issues, and we're going to go and see how we can easily solve all three of these issues. And then we're going to learn about two different types of hash tables, or rather two different strategies hash tables use to deal with these challenges: open addressing and chaining. I'm going to implement at least open addressing, and I believe I have code for both. But I'll implement open addressing, and chaining is actually fairly straightforward to understand once we get to that. All right, and then we're going to see how earlier applications can be implemented more easily using map objects for data storage. I'm going to actually, before I implement these things, I'm going to show you how we can use maps to make a lot of the stuff that we had tried doing a lot easier. Same with sets. So I'll be moving that up to the front, sort of the rationale. So you'll be able to start using them a lot sooner than before we start building them. So that's kind of our introduction to this topic, and we'll go on in the next video.